The things we see inhabiting our planet have evolved fantastic adaptations and habits to overcome issues in their environment that get in the way of an ultimate happy ending. And recently, an international collaboration led by scientists from Japan have established the first life cycle in a creature other than the famous cicadas, where they erupt from the earth all at the same time to cause havoc and interrupt human lives. Martin Kashara spoke to arthropod researcher Eleanor Drinkwater from the University of York about the research.
These trained millipedes are just remarkable because they are, first of all, they're an endemic species. They're only found in Japan. And they show this amazing behavior in which they will molt once a year, every year for 8 years. And then on the eighth year, they will have this mass emergence in which you get so many emerging that they kind of disrupt train timetables. So kind of a really dramatic life cycle that you don't see in many other species.
The researchers here, they've done a lot of hard work to find out about this periodic life cycle. Can you tell us more about how the researchers have gone about actually doing their work?
Yeah, so I think this paper is a really impressive piece of work. They've kind of really put together this huge jigsaw of so many different sources of data. So that one of the things they have done is they've gone and had a look at the train records going back into, I think the first ones they look at in the 1920s. And then they also interview different people who've been living in the areas where these emergencies happen and getting photographs from them. And then on top of that, they've gone to huge efforts to go and set out to the areas where the animals are living underground most of the time and actually digging them up at different times of the year in order to look at them and to look at their development. Really a Herculean amount of work that's gone into this paper to kind of show this kind of periodicity over 8 years. It's a really kind of impressive thesis of work. So really exciting piece of work to read.
It is the first evidence of a periodic life cycle in a non-insect. Are there other organisms that sort of go about a similar sort of life cycle?
Yes, there certainly are. And the most famous of these are probably the incredible mass emergences of cicadas. Although most cicadas have very kind of normal lifespans and they don't show this periodic behavior, you get certain species that will have mass emergences every 13 or 17 years, depending on the species. And there have been lots of different theories, one of which is a very popular theory, is the idea that it's to do with predator avoidance. If you're a prey species that only emerges once every 13 or 17 years, it's very difficult for predators to kind of sync their life cycles in order to dine out on the emergence of the species. However, that's not the only theory. In fact, Yoshimura, who is one of the top authors on this millipede study, he has been doing lots of really interesting modeling work trying to understand why an animal might go from a switch in molting behaviors, which is dependent on size. In most species, it's size dependent. So an animal gets to a certain size and then it molts into the next stage. However, this means that there will be variation in when they emerge. So if a particular animal is somewhere that's warm with lots of resources, it might molt more quickly than an individual which is in a microhabitat which is colder and has less resources. So you get that little bit of variation. However, in the case that it was the Ice Age, everything will happen much more slowly. So you have animals developing over a much slower time period due to the conditions, which in turn will lead to a lot more variation in when they emerge, which could lead to the case that you get a lower density of adults at breeding age at any one time, which is obviously bad for breeding. And so this kind of lengthening of the life cycle due to the Ice Age and those cold conditions, he argues, could have been one of the things that have triggered this switch in cicadas from this size-based molting pattern to a time-based molting pattern, because this could allow them all to kind of emerge at exactly the same time. And he also goes on to then apply this theory to what he's seeing with millipedes in Japan, which is just a really interesting concept.
You can find out more about these precocious train-disrupting millipedes in the article published in the Royal Society Open Science Journal.